back, students. Welcome to the another video lecture by Priyaslifescienceacademy. This is your educator Priya. On yesterday's class, we have discussed the several mutations of the Lac Operon, and I told you that in this class today we will practice some of the very important examples, the problems which often come in your exam. Okay, so dear students, I hope you have practiced well and have listened to the video very carefully. So today I am with the 10 problems of the Lac Operon. This type of problems will come in your exams. So these are the genotype, and we will understand what will happen when lactose is absent and what will happen when lactose is present to these genotypes. So the first genotype is I plus, P plus, O plus, Z plus. I hope you remember everything which I taught you in the previous class, that what is cis dominant, what is trans dominant, what are the different kinds of mutations of the inhibitor, operator, promoter region, and what is inducible expression, what is constitutive expression. I hope you have remembered everything very clearly. If you haven't checked the video yet, you can check out the previous video. So the first very problem is I plus, P plus, O plus, Z plus. So here you can see I plus, which will produce the wild type inhibitor. Okay. So I'm writing here I plus. Please, you also take a pen and paper and do accordingly with me, okay? So, I plus will produce the active repressor, okay? And what it will do? I plus, the active repressor will go and bind with the operator region. So, what will happen? The operator region is blocked, then the RNA polymerase can't move and the operator is blocked, then the RNA polymerase can't bind and the synthesis is stopped. So, in the absence of lactose, what will happen? There will be no expression. Okay? But what will happen if the inducer is present? Then the Lac repressors, these are the Lac repressors, and these are the inducers. What will happen when inducer is present, that is lactose, inducer will bind with the repressor and will block the repressor. Then the repressor can't bind with the operator region. Then the operator is free. So RNA polymerase can bind in the region, on the operator region, and the transcription will be started. So in the presence of lactose, the operon will be turned on. Okay. I'm requesting you all to take pen and paper and make 2 columns, lactose absent, lactose present, and do accordingly with me. So the first problem is done. Next problem, let's see. I minus, P plus, O plus, Z plus. I minus, I hope you remember, I minus produces non-functional repressor. The repressor doesn't have the ability to bind with the operator region. So in this case, the repressor can't bind with the operator region. So the operator is free. Even in the absence of the inducer also, the operator will be free because there will be no functional repressor made. So in the absence of lactose also, the operon will be turned on. And in the presence of lactose also, because there is no need of the lactose molecule or the inducer molecule. So for this operon, the expression is constitutive. I want you to write these as well. For the first operon, the expression was, yes, you guessed right, it was inducible, because when there is an absence of lactose, it was not made. Only in the presence of lactose, it was on. So that was inducible expression. But for number 2 example, that is your constitutive expression. Why? Because even in the absence of lactose, the Lac Operon is turned on. Okay. I plus P plus OC Z plus. What will happen, dear students? I plus will produce active repressor, but will the repressor bind with the operator region? Yes, you guessed right. The repressor can't bind with the operator region because the operator region is mutated. There is OC. So OC means, you know, C means constitutive. So as because the repressor can't bind with the operator region, so the operator is free even in the absence of lactose. So this again will be constitutive expression. Even in the absence of lactose or even in the presence of lactose, the operon is turned on. Because even if I plus produces functional repressor, it can't bind with the operator because the operator is mutated. There is OC mutation. It's a constitutive mutation. Okay. So even in the absence of lactose, Lac Operon is turned on. So students, coming to the number 4, I minus P plus OC Z plus. So I minus produces non-functional repressor. Okay. Non-functional, it can't bind with the operator, and again there is OC also. So even if there was I plus, so there will be no point of the repression. So Lac Operon will be turned on even in the absence of the lactose, because I minus produces non-functional repressor, no repressor to block the operator region, and if an operator is already OC, so even in the absence of lactose, Lac Operon is turned on. And presence of lactose, it is also turned on because there is OC. Even if any kind of repressor is there, OC can't allow the repressor to bind with the operator. So for this case, this is also constitutive expression. Okay. Coming to number 5, I plus P plus OC Z minus. So here I plus can produce functional repressor. Okay. But there is OC. Can it bind with the OC? No, because there is OC mutation, constitutive mutation. This Lac repressor can't recognize the operator. So the operator will be free even in the absence of lactose. So even in the absence of lactose, the operon will be turned on, and in the presence of lactose also. So this is also known as constitutive expression, because even if I plus is producing functional repressor, it can't bind with the operator because the operator is mutated. The operator is OC, so it can't recognize the Lac repressor. So the Lac repressor can't recognize the operator. So the operator will be free, and even in the absence of lactose, it will be turned on. So this is also an example of constitutive expression. So completed number 5. Now coming to number 6. I plus P plus OC Z minus I plus P plus O plus Z plus. Now this is the example of partial diploid. Okay. Number 1 to 5 was only for single chromosome, and from 6 to 10 it is partial diploid, and these are the real problems, because the bacteria are partial diploids only. So now coming to the problem, the first chromosome can produce I plus, and the first chromosome can produce active repressor. The second chromosome also can produce active repressor. But you have to know, and these I plus, they both are transdominant. They can affect their own chromosome as well. They can affect the other chromosome. But here you can see in the first chromosome there is OC. And you know that the repressor can't recognize the OC because operator is mutated. That is why the repressor can't recognize the operator. So in this case, for the first chromosome, the repressor can't bind with the operator, but for the second case, the repressor can bind easily with the operator. So in the absence of lactose, for the first chromosome, the action will be constitutive. Why? Because even in the absence of lactose, the first operon will be turned on. Okay, but the second operon is turned off because the I plus can recognize the wild type operator easily, so it is turned off in the absence of lactose. But when there is a presence of lactose, what will happen? The first operon, there is no point of bothering, but for the second operon, when the inducers are there, the inducer will block the repressor, and the repressor can no longer bind with the wild type operator region. Then the operator will be free and the operon will be turned on. So for the second operon, it is inducible expression. Okay, for 6, what we will write? In the absence of lactose, it is turned on. Okay, and in the presence of lactose also, for number 1, number 2. For the for first operon, in the absence of lactose, it is turned on, and in the presence of lactose, it is also turned on. For the second operon, in the absence of lactose, it is turned off, and in the presence of lactose, it is turned on. So for the first operon, it is constitutive expression, C for constitutive, and for the second operon, it is inducible expression, I for inducible. Okay, so you have to think like that. Now we will go for 7. I plus P plus O plus Z minus, I plus P plus O plus Z minus. So from both of the operon, that is I plus, there will be functional active repressor, and the active repressor can bind easily with the operator region because the operator is wild type, that is O plus. They can bind with their respective operator. Also they can bind their neighbors as well. These can bind here also and these can bind here also because they are transdominant. So in both the operon, the operator is blocked by the I plus because they are producing active repressors and the operators are also active. So in the absence of lactose, what will happen? Both the operons are turned off. Okay, so for 7, number 1, number 2. So number 1 operon also, in the absence of lactose, it is turned off, and number 2 also, in the absence of lactose, it is turned off. But what will happen when there will be the presence of lactose, which is inducer? It will block the repressor and the repressor will no longer can bind with the operator region. Then the operator will be free, and then from both the operon there will be the expression of the Lac Operon. Okay, so the Lac Operon will be expressed in the presence of lactose when the operators will be free and when the inducer can block the Lac repressor. Okay, but in this case there will be the expression of the operon, but you can see Z minus, Z minus. Beta-galactosidase will be produced, but it will be non-functional. So in this case you have to write non-functional beta-galactosidase. Okay, non-functional beta-galactosidase. And for both of the operon, it is, yes, you guessed right, it is inducible operon, because because when you are giving lactose, then only the operons are turned on. So for both of them it is inducible because it needs an induction for it to turn on. Here you can see the number first operon, it can produce active repressor, and I minus can't produce active repressor. But even if I minus can't produce active repressor, you know the inhibitors are transactive, so it can transport its repressors to the next operon. So from here active repressors will be made and it can travel to this operator and can block this operator. But in this case, this inhibitor can't bind with the OC. It can't bind with the OC because the operator is mutated. So what will happen for number 9? In the absence of lactose, the first operon is turned on. Why? Because even if there is a active repressor, the repressor can't block the operator because the operator is mutated, that is OC. So even in the absence of lactose, the operon is turned on. Okay, but for number 2, what will happen? Number 2, here the I minus can't produce repressor, but the I plus from this chromosome can travel and can block this operator. So here no expression is seen. So in the absence of lactose, for number 2, there is no expression. But what will happen when there will be the presence of lactose? You know that number 1 operon doesn't matter. So the expression will be 1 for operon 1, but for operon 2, the presence of inducer matters a lot, because the I plus which was blocking the operator, now it is blocked itself by the inducer. So when inducer is present, it can block the repressor. Then the repressor can't bind with the operator region. Then the operator will be free. What will happen in the presence of lactose? In the presence of lactose, so no repressor is there to bind with the O plus. The O plus is free, then the transcription is on, then the Lac Operon will be turned on. So the second operon is inducible because whenever lactose is present, it can be turned on. So the first operon is constitutive operon and the second operon is inducible operon. And point to be noted, even the first operon is constitutive, the Z will be non-functional beta-galactosidase as because it is Z minus. Okay. Now coming to the last problem, which is I minus P plus O plus Z minus P plus OC Z plus. Now what can you see here? That from both of the operon, no functional repressor can be made because both are I minus. So what will happen? There is O plus, there is OC. Even in the absence of lactose, the Lac Operon is turned on. Because in both of the operon, there is I minus. No repressors to block the operator. So for the first operon also, so what is number 10? For the first operon also, even in the absence of lactose, operator is free. The RNA polymerase can go easily and can turn on the expression of the Lac Operon. So even in the absence of lactose, Lac Operon is turned on. And in case of this second operon, there also Lac Operon will be turned on because here is OC. Okay, even if repressor is present, OC will not allow to bind it in the operator region. But in this case, there is no repressor also and there is a mutation OC. So it will allow the expression of the Lac Operon even in the absence of lactose. And in the presence of lactose also. So these two operons are constitutive. Okay, because both are expressed even in the absence of lactose. I hope you understood the problems very nicely. I want you to practice them thoroughly. These type of problems will come in your exams, in any kind of exams. It can be BSc, MSc, NET, NEET, in any kind of exam in GET. So I want you to practice this very thoroughly. And if you have any problems, you can comment below and I will happy to give you the suitable answer. And if you have any problem of Lac Operon by your side, you can also post it and you can also mail me. My mail ID is given. So you can ask me and I'll give you the suitable reply. I'll try to give my best answer to you all. Most of the mutations associated with inhibitor. So this is the wild type inhibitor. These are the mutated inhibitor. Okay, so what is the difference? I want you to give a very quick revision that I plus produces active repressor. Okay, I minus produces inactive repressor. Okay, it produces inactive repressor where the operator binding site is mutated. Operator binding site is mutated. Okay, and IS produces super repressor. Here, the inducer binding site is mutated. I hope now you can get the idea, because in this case, in case of I minus, the operator is mutated, like in both of the case, I minus also mutated, I is also mutated. But in case of I minus, the operator binding site is mutated. That is why it is an inactive repressor. But in case of IS, the inducer binding site is inactivated. The inducer binding site is mutated. That is why even if the presence of inducer, the inducer can't bind with the repressor region. Okay. That is why it is known as super repressor. But in this case, in case of IS, the operator binding site is okay. So it can bind with the operator very easily, but it can't bind with the inducer. That is why the problem arises, and it is known as the super repressor, because the super repressor can't be blocked by the inducers also. There is another kind of inhibitor mutation which is less discussed, but I want you to know. That is I minus D. I told you in the previous class, that is dominance mutation. I minus D produces non-functional repressor. Like, the repressor proteins are made with, the repressor proteins are the tetramer of 4 proteins. Okay, so it can't produce all of the peptides very nicely. For example, it can produce the 2 peptides nicely, 3 peptides nicely. Okay, so if there is a partial diploid, if here is I plus and I minus D, and here is O plus, the I plus D can't function well, because if the I plus can produce the active repressor, this I minus D which produce the inactive repressor, the inactive part can block the repressors produced by the I plus. Okay, so in this case, whenever there is I plus and I minus D in a partial diploid, the operon will be constitutively expressed. Okay, there will be constitutive expression of the Lac Operon, because I minus D produces very much inactive repressors, and that inactive repressor can also block the functionality of the active repressors produced by I plus. Okay, this point you have to take in your mind, because this type of new problem can arise in a lot of exams. So you must remember that I minus D produces non-functional repressor. Their polypeptides are very, very fragile, and not all of the subunits are made properly. So the fragile subunits can block the expression of the active repressors as well. So in case of I plus D, I minus D, this operator will be constitutively active. Okay, you have to remember, this is constitutive expression whenever you see I plus I minus D. Okay, so I hope you understood, students. Thank you for listening. I wish you all the best. Fight for your dreams, and your dreams will fight for you. Thank you so much.